next question is for block diagram shown in figure C of S by R of S is given by this. This is the block diagram and here are the four options given. So first of all, here we will find the number of forward paths. How many forward paths are there? So here G1, G2, G3, only one forward path is there. So P1 is equal to G1, G2 and G3 are the gain products. And let's find the number of loops. G1, G2, H1, G2, G3, H2. So two loops are there, minus G1, G2, H1 and L2 is equal to minus G2, G3, H2. And non-touching loop 0. So by using Mason gain formula, the transfer function is equal to P1 delta 1 by delta, as only one forward path is there. So let's substitute the gain value G1, G2, G3, 1 minus G2, G3, H2 minus G1, G2, H1, G1, G2, G3 by 1 plus G1, G2, H1 plus G2, G3, H2. So this is the answer, and from here option A is the correct answer. And the next question is for the block diagram shown in figure, the transfer function is equal to, this is the block diagram and here are the four options given. So from here we have to find the transfer function. So let's see the solution. So here number of forward paths, one by S, only, sorry, one forward path, second forward path, third. Here three forward path is there. So P1 is equal to 1 by S square, P2 is equal to 1 by S and P3 is equal to 1 by only 1. Let's see the number of loops. So here no loops is there, so number of loop is 0. So the transfer function is equal to P1 delta 1 plus P2 delta 2 plus P3 delta 3 by delta. So here we will get 1 by S square into 1 plus 1 by S into 1 plus 1 by 1 minus 0. 1 by S square plus 1 by S plus 1, S square plus S plus 1. By taking the LCM we will get. So option B is the correct answer. The next question is, the block diagram of a control system is shown in figure. The transfer function G of S is equal to Y of S by U of S of the system is. So here is the block diagram, and from here we have to find the transfer function. So let's see the solution. Integrator, it means its gain is 1 by S. Okay, so let's find the forward path. One forward path, only one forward path is there. So P1 is equal to 2 by S square, as 2 integrator is there, and number of loops 1, 2, 3. 3 loops are there. So L1 is equal to minus 3 by S, as it is negative feedback. L2 is equal to minus 12 by S and L3 is equal to, it's also negative feedback, so minus 9 by 9 into 2 by S square minus 18 by S square. And here two non-touching loops are there. this and this loops are not touching to each other, so two non-touching loops. Its again product is minus 3 by s and minus 12 by s. So let's see, the transfer function is equal to p1 delta 1 by delta, so 2 by s square into 1 and 1 minus number of sum of the individual loops, that is minus 3 by s minus 12 by s minus 18 by s square plus two non-touching loops, so their gain product is minus 3 by s into minus 12 by s is 36 by s square. So 2 by s square by 1 plus 3 by s, open the bracket, 12 by s plus 18 by s square plus 36 by s square. Now take the LCM and we get 2 by square into s square plus, so 2 by s square plus 3s plus 12s plus 18 plus 36 s square will get cancelled, so we will get 2 by s square plus 3s plus 12s plus 18 plus 36. Here 2 by s square plus 15s plus 54 s square plus 6s plus 9s plus 54 into 2 by s into s plus 6 s plus s common, here we will take 9 common, so s plus 6 2 by s plus 6 s plus 9 is equal to, when we will take 6 common, 1 plus s by 6 and take 9 common, s by 9 plus 1, so we will get 2 3 is 1 by 27, 1 plus s by 6, s by 9 plus 1, so option B is the correct answer. And the next question is, the signal flow graph of a system is given below. The transfer function y of s by u of s for this system is, so here is the signal flow graph given, and here we have to find the y of s by u of s. So let's see the solution, and first of all we will find here number of forward paths. So here first forward path, second forward path, two forward path is there, and its gain is p1 is equal to 1 by s square and p2 is equal to s inverse 1, so 1 by s. Let's see the number of loops. First loop, second loop, third loop, fourth loop. So 4 loops are there, and L1 is equal to minus 2 by s square, L2 is equal to minus 4 by L3 is equal to, and L4 is equal to minus 4. So by using Mason's gain formula, as delta 1 is equal to 1 and delta 2 is also equal to 1, because all the loops are touching to the forward path, and transfer function is equal to P1 delta 1 plus P2 delta 2 by delta. So by putting the value, we get 1 by s square plus 1 by s by 1 plus 2 by s square plus 4 by s plus 2 by s plus 4. So here we get s plus 1 by s square by taking the LCM, s square plus 2 plus 4s plus 2s plus 4s square by s square. S square will get cancelled, and here we'll get s plus 1 by 5s square plus 4s plus 2. So this is the answer. Next question is, the block diagram of a system is shown in the figure. Here is the block diagram, and if the desired transfer function of the system is c of s by r of s is equal to 1 by s square plus s plus 1, then g of s is, and these are the 4 options given. So let's see the solution. Number of forward path is 1. Only one forward path is there. So P1 is equal to g of s, as 1 by s will get cancelled, g of s. Otherwise write g of s into s, g of s. And the number of loops is 1, 2, 3. 3 loops are there. So L1 is equal to g of s by s, L2 is equal to g of s, L3 is equal to sg of s. As it is negative feedback, so minus g of s by s, minus g of s minus sg of s. And from here the transfer function is equal to P1 delta 1 by delta. So we will get g of s by 1 plus g of s by s plus g of s plus sg of s. By taking the LCM, we will get g of s by s plus g of s plus sg of s plus s square g of s by s, sg of s by s plus s square g of s plus s plus 1 g of s plus s. So this is the answer, and from the given answer we are not getting any options. So the next question is, find the transfer function y of s by x of s of the system given below. And here are the 4 options given, and this is the block diagram of a system. So let's find the transfer function. Number of forward paths from x of s to y of s is 1, 2. 2 forward path is there, so its gain product is P1 is equal to G1, P2 is equal to G2. Let's see the loops, number of loops. Number of loops two loops are there. So L1 is equal to minus G1 H1, sorry, minus G1 H, and L2 is equal to minus G2 H. And here non-touching loop is 0, so transfer function is equal to P1 delta 1 plus P2 delta 2 by delta. We will get G1 plus G2 by 1 plus G1H plus G2H. So take common G1 plus G2 by 1 plus G1 plus G2 into H. Option C is the correct answer. Next, in the system whose signal flow graph is shown in the figure, U1 of U1 of S plus U2 of S are inputs. The transfer function Y of S by U1 of S is, here are the four options given, and this is the signal flow graph. So let's see the solution. Here also same procedure. We will find the number of forward paths. First forward path. So only one forward path is there. If we consider U1 is the input, so P1 is equal to 1 by L 1 by S into K1 into 1 by J into 1 by S. So P1 is equal to K1 by JL square, and number of loops. Let's see the number of loops. 1, 2. 2 loops are there, and its gain product is L1 is equal to minus R by LS, and L2 is equal to minus K1 K2 by JL S square. So by using the Mason gain formula, the transfer function is equal to P1 delta 1 by delta. So K1 by JLS square by 1 plus R by LS plus K1 K2 by JLS square. So let's take the LCM. So we'll get K1 by JLS square by JLS square plus JRS plus K1 K2 by JLS square. This will get cancelled, and we will get K1 by JLS square plus JRS plus K1 K2. So this is the answer, and from here we get option A is the correct answer. This is all about the GATE previous year questions from signal flow graph by using Mason's gain formula.